Okay, in this video we're going to talk about transformations of functions, which is a very important topic later on down the road, especially when we start graphing trigonometric functions. And also whenever you get into the calculus, you're going to be graphing and doing a lot of other things, and you really need to understand what's going on with transformations of functions. On the board, I've drawn the graph of a very basic function, y equals the square root of x. We're going to say this is the point 0, 0, and we're going to say this is the point 1, 1. We're going to talk about some transformations with this function. Now first I want to talk about shifts of domain or shifts on the range. When you add a number, you do exactly what you think it does exactly what you think it ought to do. It moves you up. When you subtract a number, it moves you down. So shifts on the y-axis do exactly what most folks think they ought to do. Adding moves you up, subtracting moves you down. So if I took and looked at, say, f of x plus 2. Well, remember this 2, if you think of f of x as the range and x as your domain, this makes this life a whole lot simpler. This 2 affects the range of this function. So it's going to add 2, it's going to shift everything up 2 units. A rough sketch of this would look something like this. The point that was at 0, 0 goes to 0, 2, and we're basically adding 2 to all the y values. So this point, instead of being 0, 0, is now 0, 2. And this point, instead of being 1, 1, is now 1, and 1 plus 2 is 3. So that's going to be the point 1, 3. Subtracting does the opposite. It's just going to move you down. Now let's talk about a shift on the domain. Shifts on the domain run backwards from the way a lot of folks think they ought to run. When you add a number, it's going to move you to the left. When you subtract a number, it's going to move you to the right. You can think of it as what number do you have to put in to get to the original position. For example, if we think about f of x minus 2. Okay. Well, what number would I have to put in here for x to get 0? It would be 2, wouldn't it? So this point that was at 0, 0 goes to 2, 0. This point that was at 1, 1, it's going to be shifted 2 units to the right. So my graph is going to look something like this. The point that was at 0, 0 goes to 2, 0. The point that was at 1, 1, well, we're not doing anything to y, but we're shifting the domain. What can I put in here that's going to give me a 1? Well, 3 minus 2 is 1. So this is going to be the point 3, 1. Okay? That's one way of thinking of it. Another way is if I take 1, add 2 to it, 1 plus 2 gives me 3. Either way, we wind up with 3. If we talked about, say, f of x plus 4, what's that going to do? Well, now it's going to move us 4 units to the left. Okay? So this point that was at 0, 0 goes to negative 4, 0. The point that was at 1, 1, well, now instead of being 1, what can I put in here that gives me a value of 1? What makes this, in other words, x plus 4 equals 1, what's x? Well, negative 3. So this graph is going to look something like this, and this will be the point negative 3, 1. Okay, now let's talk about some reflections. Okay, if you think about negative times f of x, well, is that affecting your domain or your range? In this case, it's affecting your range. Like here, this is affecting domain. It's inside the parentheses. Here, this is affecting the range. It's outside the parentheses. This negative sign is outside the parentheses, so it affects our range. And if you think of it, you're effectively multiplying all the y values by negative 1. So what you're going to see is a reflection across the x-axis. This is still the point 0, 0, but you're multiplying all the y values by negative 1. So this point that was at 1, 1 now becomes 1, negative 1. Okay? Now, if we think about f of negative x, well, that's an effect on the range, and you're effectively or essentially flipping the graph across the y-axis. You're going to see a reflection across the y-axis. So now, well, the point is at 0, 0. Negative 0 is still 0, but you're doing what? You're flip-flopping your x-axis. So this graph will look something like this. This is still the point 0, 0, but the point that was at 1, 1 now becomes negative 1, 1. Okay? There's some basic transformations of functions, the essential ones. We're going to get into some more. We're going to look at shrinking and stretching, but we'll do that later on down the road. Thanks.